For these notes, we're going to be learning about the triangle inequality theorem and the side angle relationship that exists in triangles. The first standard talks about using the triangle inequality theorem to find a range of possible side lengths for the third side of a triangle if I give you two sides, and being able to use the triangle inequality theorem to determine if a given set of side lengths can actually make a triangle. So the first thing I want to do is write down what is the triangle inequality theorem. So the triangle inequality theorem states that the sum of any two sides of a triangle must be greater than the third side. So the sum of any two sides of a triangle must be greater than the third side. Otherwise, it wouldn't be able to close to actually connect and make a triangle. So for example, if I drew a triangle here, and I said this side was 5, this side was 8, and let's say this side here is 10. If I add any of the two sides together, it'll be greater than the third side. In reality, the ones you have to check are the two smaller sides. 5 plus 8 is 13, which is bigger than 10, so this works. All right, if you wanted to check all the sides, 5 plus 10 is 15, it's bigger than 8. 8 plus 10 is 18, bigger than 5. So this works. So this is a triangle. But if I drew one, you can draw anything and put numbers to it, but let's say I did 5, 8, and let's say I did 16 here. 5 plus 8 is 13. 13 is not bigger than 16. So this is not a triangle, or I should say cannot be a triangle. Okay, you can put any numbers you want on a drawing, but in reality, if we were trying to construct that triangle, we would not be able to do it because you need the two smaller sides to be greater than that third side. So there's two types of problems that you will be asked. First set of directions say determine if it is possible for a triangle to have the following side lengths. We have to explain or show our reasoning. So you can explain using words if that helps you, or you have to show your work. You cannot just write yes or no and move on, or you will not get the 400 score. So in order to do this, let's jot down how we would do this. So we were going to take the sum of the two smallest sides to see if it's greater than the third side. So we're going to take the sum means addition, of the two smallest sides to see if it's greater than the third side. If it is greater, then yes, it's possible for it to be a triangle. If it's not greater, then no, it is not possible for it to be a triangle. So if we look at the first example, the two smaller numbers are 13 and 14. So I'm going to take the sum, which means add, 13 plus 14, which gives me 27. So now we have to check, is this sum that I got, 27, so I'm getting 27 from the sum, is it greater than the third side here, which is 24? And the answer is yes, 27 is greater than 24, so yes, this is possible to be a triangle. If you show me this work, that accounts for showing your reasoning. If you didn't show any work and just wrote yes, then that does not count for showing your reasoning. So let's check the next example. So I'm going to sum the two smallest sides. The two smallest sides here are 11 and 14. So 11 plus 14 is 25. So now we have to check, is 25 the sum we got? Is it greater than the third side, which is 29? Well, in this case, 25 is not greater than 29. So no, it is not possible for this to be a triangle. The directions say determine if it's possible to be a triangle. In this case, no, it is not. Let's try another one. So for number 3, the two smaller ones, remember, it doesn't always go in order. Here, the two smaller ones are 5 and 14, the second and third numbers in our list. So check, 5 plus 14 is 19. So we have to check, is 19 greater than that third side here, which is 21? And again, the answer is no, it is not. Let's do a couple more. So for number 4, the two smaller sides are 31 and 22. So I will take the sum. 31 plus 22 is 53. So we're checking, is this sum, 53, is it greater than the third side, which is 42? 53 is greater than 42. It's a true statement. So yes, it is possible to have a triangle with those side lengths. Number 5, the two smaller sides are 4 and 5. So I'll add those. 4 plus 5 is 9. So now we're going to see, is 9 greater than the third side option, which is also 9? And this sometimes will stump people, but it's strictly greater than. It's not greater than or equal to. It's greater than. 9 is not greater than 9. So this is an example of no, it is not possible for it to be a triangle. So those are the first type of problems. I'm going to skip number 6 for now. Same idea though. The next type of question that you could be asked regarding the standard is the directions say two sides of a triangle have the following measures. Find the range of possible measures for the third side. Show all your work for proof of understanding. So again, I need to see the work you're doing to show me you really understand it. So now they're giving me 2 of the 3 sides, and we have to determine, well, what are the possible options for the third side? Okay, so we're going to come up with a range of possible options for the third side. So we don't know if they gave us the 2 biggest sides of the triangle. We don't know if they gave us the 2 smaller sides of the triangle. So we have to account for both possibilities. So the way we can come up with a range, so from a certain number to a certain number of possible measures for the third side, first thing we would do is we're going to add these 2 numbers. So we're going to assume they're the 2 smallest sides. So I'm going to do 12 plus 14, which is 26. Okay. So now we're going to assume they're the 2 largest sides, and we're going to subtract the 2 numbers. 14 minus 12, which is 2. So our third side has to be between these 2 numbers for it to work and actually be possible to be a triangle. So the way we write this, we're going to set it up as an inequality to show a range of possible measures. So 2 is less than x, which is less than 26. So that what this statement says, this x represents the third side. So the third side has to be between 2 and 26. So if you wanted it in words, you would write it has to be between 2 and 26. So we assume they're the 2 smallest sides, we add them. We assume they're the 2 biggest sides, we subtract them. And we know our third side has to be some number between the 2 numbers. So in this case, 2 and 26. All right, let's do another one. So for number 8, again, assume they're the smaller sides and add them. 2 plus 6 is 8. Now we're going to assume they're the 2 smaller sides and larger sides and subtract them. 6 minus 2 is 4. So we know the third side for this triangle has to be between these 2 numbers. And again, we're going to write it as an inequality. So what this inequality says is the third side is between 4 and 8. So possible options would be 5, 6, and 7. So the third side has to either be 5, 6, or 7 for that to be a triangle. The next one, again, assume they're the smaller sides and add them. So 25 plus 41, which is 66. Assume that they are the bigger sides and subtract them. 41 minus 25, 16. So our third side must be between these two numbers. And we're going to write that as an inequality. 16 less than x less than 66. So again, the statement says that the third side is between 16 and 66. So that process repeats for that section. So again, when it asks you to find a range of possible sides, you want to see what possible side lengths could be the third side of the triangle when they give you the first two side lengths. So the next standard that we're going to talk about has to deal with the side angle postulate. So we're going to be able to use the side angle postulate in order to order side lengths and angle measures. So we want to be able to use the relationships between triangle sides and its angles to order the sides from least to greatest or greatest to least. We want to use the same relationships to order angles. Again, and we're going to read directions to see if they want least to greatest or greatest to least. So what does the side angle inequality conjecture state? Well, it states that the longest side is across from the largest angle same pattern, the shortest side is across from the smallest angle and the one in the middle, so the mid-size, I'll call it, side, is across from the mid-size angle. So the longest side of the triangle has to be directly across or opposite of the largest angle. The shortest side of the triangle has to be directly across or opposite from the smallest angle, and same with the middle sides. Okay? So in this triangle over here, we're just going to make up an example. So I'm going to call this angle here 50 degrees, this angle here 30 degrees, and the angle up top 100 degrees. So according to this side angle inequality conjecture, the longest side should be across from the biggest angle, 100 degrees. All right, so this should be the longest side. The smallest side should be across from the smallest angle. Well, 30 degrees is the smallest angle I put in this example, so this should be the shortest side. The middle angle here, 50 degrees, again, across from that would be the mid-size side, or the middle side. Okay? I highly recommend that you draw arrows so that you know you're going directly across from the angle or side you're trying to look at. So let's do a few examples. So the first set of examples want us to name the angles, and again, read directions. We want smallest to largest. So we're naming the angles from smallest to largest. Well, in order for me to know what the smallest angle is, I have to look for the shortest side length, so I know I can look directly across from it. So here, in this first example, I have sides of 5, 3, and 7. So the shortest side is 3, so directly across from that would be the smallest angle. So angle A would be the smallest. You have to write it this way. You have to put the angle symbol and then the capital letter A. Comma. The next biggest side, so 3 is the shortest side, and if I'm going from shortest to largest, I need the middle side now. 5 is in between 7 and 3, so that's the next biggest side. And the angle that's across from that is angle B. So angle A is first, angle B is second. Which means that the largest angle should be across from the longest side. So the longest side is 7, which means the largest angle in this case is C. So you always want to list them in order, for whatever order they're telling you, either smallest to largest or largest to smallest. You have to list them using the angle symbol with a capital letter and separate them with a comma. So let's do another example. Again, the same direction, smallest to largest. I have side lengths of 15, 10, and 12. So again, smallest angle is across from the shortest side. So 10 is the shortest side, and that's across from angle A. The next biggest side is 12, and that's across from this angle here, angle B. So angle B is next. The largest angle is across from the longest side, so in this case, angle C. Now, it is a coincidence that both of these were in alphabetical order. It is not always going to be an alphabetical order thing, so you must pay attention to each particular problem. So let's go the opposite way. Here they wanted us to order the angles, but now they want us to do it with side lengths. So here they want us to name the side lengths of the triangles from the longest to shortest. So now I want the longest side first and the shortest side last. So in this first one, the longest side, which we want to do first, should be across from the largest angle. So my angles here are 55 degrees, 80 degrees, and 45 degrees. So the largest angle is 80. So across from that angle should be the longest side of the triangle. Now the way we would write the side length is we look at the two endpoints of the side. In this case, the endpoints are X and Y. So I'm going to write capital X, capital Y. And then you have to put this segment symbol above it. Now, the order of the letters doesn't matter. So if you wrote, I'll write or, you don't have to write both. So if you wrote YX with the symbol above it, that is the same thing and it doesn't matter. You don't have to write it both ways, but you do have to make sure you're using capital letters and you're putting that segment above it. Okay. So that was the longest side. It wants longest to shortest. So the next biggest side after 80 is 55. So the next biggest side across from that would be ZY, or you could say YZ. It does not matter. So ZY would be next. The shortest side should be across from the smallest angle. The smallest angle here is 45 degrees, and that's across from side XZ, or you could say ZX. So from longest to shortest. Again, you're listing the sides using two capital letters with a segment above it. And you can switch the order the two letters are in. The next one. I'm looking at this and I'm like, I think Mrs. Kame forgot to put the angle measure for angle A. But I didn't. Because we know enough facts about triangles to be able to figure out what that angle measure is. So they gave me 2 out of the 3 angles, 30 degrees and 70 degrees. So we recall that triangle sum states all interior angles of a triangle has to equal 180. So before I can start ordering my sides, I need to know what angle A is going to equal. So I can solve that. So if they're all 180, I can do 180 minus the 2 that they gave me, 30 and 70, to see what's left over. And in this case, 80 degrees is left over, so angle A is 80 degrees. So now that I've found the missing angle, I can now order my sides from longest to shortest. So again, longest side is across from the largest angle. 80 degrees is the largest angle. So across from that is side BC. The next largest angle is 70 degrees, which is across from side BA or AB. The shortest side across from the smallest angle, 30 degrees is the smallest angle, and side AC would then be the shortest side of the triangle. The last example. So longest to shortest. The largest angle here out of 20, 70 and 90 is 90. So the longest side across from that would be LM or ML. The next largest angle is 70 degrees. So across from that is side LK or KL. And the shortest side across from the smallest angle is MK. So in these notes, and you should now be able to do your practice, we talked about the triangle inequality theorem, which states, the sum of the two smallest sides has to be greater than the third side. So we found the two smallest sides, we added them, that sum, to see if that sum was greater than the third side. If it was, yes, it's possible that they were a triangle. If it was not, then no, it is not possible that those are side lengths of a triangle. Then we talked about how to find a range of possible measures. So we assumed the two sides they gave us were the smallest sides and the biggest sides, so we can determine the range of possible numbers the third side could be. And we wrote them as an inequality. And the inequality says it's between these two numbers, that third side. Lastly, we talked about the side angle inequality conjecture, the longest sides across from the largest angle, shortest sides across from the smallest angle, etc. And we read directions to know how they wanted us to order our sides, either smallest to largest or longest to shortest.